Also a very warm welcome to our webinar about DevOps and AI. My name is Paul, and together with my colleague Matti, we will guide you through today's presentation. Please bear with us as we're just taking our first steps in this kind of presentation, and we're still learning and enhancing our knowledge base. But let's get into it. Now, as already mentioned, today's webinar will be about the DevOps processes as we know them and how AI can step into this to help us improve them. Note that this will not be a deep dive into AI and how everything works down to every technical detail, but rather a high-level overview of how AI can be used in the field of DevOps and why it's cool to use. And with that being said, Matti will introduce us to today's agenda.
Thank you, Paul. Let's have a quick overview of what we're going to cover. We'll first start by revisiting a few key elements of the DevOps process. What are each individual steps? After that, we'll explore the concepts of artificial intelligence and generative AI, and also delve into large language models. After that, after we've built a little bit of foundation, I will discuss the pivotal role of AI in the DevOps process and how it can enhance it. We'll also examine some leading AI tools available for our DevOps processes. And finally, we will wrap everything up with strategies for how to effectively implement AI in our DevOps workflow. With that stated, let's get started and dive right into it. What is DevOps? At its core, DevOps is much more than a set of tools. In my opinion, it's a combination of practices, tools, and perhaps most importantly, a culture. The goal of DevOps is to break down the traditional barriers and divisions between software development and IT operation teams, bringing them together through automation and integration. The philosophy of DevOps emphasizes three key areas: collaboration, communication, and continuous improvement. DevOps therefore encourages teams to work closely together rather than in isolation, by aligning their goals and processes. Now, let's have a look at each individual process in the DevOps lifecycle, starting with the planning phase. Planning is the foundation of the DevOps workflow, setting the direction for everything that follows. In the planning stage, teams work together to define goals, establish timelines, and organize tasks. It's not just developers that are involved here. This process involves collaboration between various stakeholders, from business leaders to product managers and even end users. The collaboration ensures that features are prioritized effectively and that the project requirements are well understood from the get-go. Aligning development efforts with the business objectives and timelines is key in this phase. Planning acts therefore as a checkpoint of sorts to make sure everyone is on the same page and working towards the same outcome. Tools we can use here, for example, well-known tools like Jira or Trello. Now let's move on to the coding phase. Coding is where the development teams actively write, review, and manage the application source code. Developers work together in this phase to both build new features and continuously improve on existing code. It's a collaborative effort to maintain code quality and ensure that applications remain stable as they evolve. An important part of this is, of course, using version control to track all changes, so everyone can see what's been modified, who made the changes, and when they were made. To support these activities, we can use common tools like Git and also IDEs like VS Code. Next, let's have a look at the building phase in this process. Building is where the written code is then compiled and packaged into executable formats. This is a crucial step as it transforms the source code we've previously written into a form that can be run and tested by the system. The building process involves several steps such as resolving dependencies, ensuring all libraries or external resources for the application needs are in place, and running automated tasks like coding, code linting, or initial tests. To achieve all this effectively, we need tools like, for example, Maven or Gradle. which I'm sure many of you have heard of. In the testing phase, testing is essential for validating and verifying that the software behaves as we expect it to behave. In this phase, we run automated tests to catch bugs, check for performance issues, and ensure the overall quality of the application. Testing isn't just about finding new issues, it's about making sure that the recent changes we made to our code don't disturb existing functionality. Testing includes a range of activities from unit testing to integration testing, which tests the whole functionality from start to finish of an application. There are numerous tools we can use here, for example, Selenium or JUnit are two very well-known tools we can use here, for example. Now, let's dive into the release phase of this pipeline. This phase focuses on preparing and automating the deployment of code into production environments. It's a critical step because it ensures that the code changes are not just developed and tested, but also integrated and delivered to the end user effectively. The release process involves several key aspects such as managing different versions of the software, handling necessary approvals, and ensuring that the release process is seamless and risk-free. Tools we can use here, for example, are Circle CI, GitLab CI/CD, or in case of GitHub, GitHub Actions, and Jenkins, for example. Moving on to the deploying phase. Deploying is where the code gets put into action, and it involves configuring the infrastructure necessary to run applications in various environments, whether that's deployment, development, staging, or production. This phase encompasses critical processes such as automating infrastructure provisioning to ensure the right resources are available at the right time, managing the configuration to align with application requirements, and scaling applications to handle varying loads. To support this, we can use tools like, for example, Kubernetes for container orchestration, Ansible for configuration management, or Terraform for infrastructure provisioning. And finally, we come to the operating monitoring phase, which is crucial for the long-term success of applications. This phase involves managing both the application and the underlying infrastructure, while continuously observing the performance and overall health. In this stage, teams focus on collecting vital metrics, logs, and traces to detect and diagnose any issues that may arise during the operation of the application or the software. This proactive approach ensures that systems remain resilient and performant. To facilitate this, we can use tools such as Prometheus to gather metrics, or for example, Grafana to display these metrics, logs, and traces, or whatever we gather in a user-friendly way for the end user, or in this case, most likely the developer. Now that we know the traditional DevOps processes, why would we want to use AI for them? What's the problem we are facing? First, we have manual and error-prone processes. Traditional DevOps often relies heavily on manual intervention, which can lead to inefficiencies, and repetitive tasks consume valuable time and increase the likelihood of human error. Next is the issue of delayed issue detection and response. Without real-time data processing, teams may struggle to detect and react to issues swiftly. This can result in prolonged downtimes and significantly hamper the ability to handle critical incidents effectively. Another challenge is the skill gap between teams. Collaborating between development and operations can be hindered by differences in technical expertise, which can make it difficult to maintain consistent efficiency and productivity across these teams. Then there are scalability issues. As DevOps teams strive to scale their operations in dynamic environments, they often face challenges due to the lack of automation and AI-driven processes that could elevate the burdens of growth. This can hinder their ability to keep up with the increasing demand. We must also consider the security vulnerabilities, of course. Security always plays a huge role. The absence of real-time threat detection and automation, automated defenses can increase the risk of cyber attacks, data breaches, and other security incidents. And lastly, there's the inability to adapt to rapid changes in today's fast-evolving digital landscape. Businesses that fail to adopt advanced AI-driven solutions can often risk falling behind competitors. And now my colleague Paul will tell you a little bit about AI and Gen AI.
Yes, thank you, Matti, for your great overview of the important DevOps processes, but also the challenges we might face in them. So, all right, AI, let's now step into the magic world of artificial intelligence. Now, I think by now everyone has already come across AI somewhere. I mean, we all know ChatGPT, for example, or Amazon's Alexa, or maybe even Claude's new computer use feature, which basically promises to overtake our computer and render us humans useless. No, jokes aside, we know that AI is a very broad field and it can be used in very many different ways. But in our context, I think it wouldn't hurt to understand certain terms or processes or concepts to get a better understanding of how AI actually supports our workflow. So let's start from the bottom. What does artificial intelligence really mean? We know AI, which is short for artificial intelligence, is about simulating or sort of mimicking human intelligence processes, which is done by machines or computer systems. And these processes typically include things like learning, reasoning, or self-correction. And we know that AI is a very broad field that includes a very wide range of applications from, let's say, any chatbots or virtual assistants to self-driving cars or even medical diagnosis systems. But there is one specific field of AI which has made a big step forward and also a big impact in the last few years, which is generative AI. And generative AI is a subset of artificial intelligence, which, well, as the name already suggests, focuses on generating new content such as texts, images, or even audio. And it creates new data that was originally trained on its knowledge base of any existing data, often using large language models or LLMs. We will dive into that in a moment to generate any human-like content. So, as you might think, generative AI has a wide range of applications from language understanding, creative writing, and content generation to image synthesis or music composition. But why is this important? Well, as Gen AI can analyze and generate new content based on human understanding, it can be used to automate tasks which would typically require human-like creativity, understanding, or thinking, such as writing an article or a technical report or whatever, or generating code snippets, or just helping us with tasks which would, again, require our human creativity. Which now brings me further to a specific AI model, which is called the large language models, or short LLMs, which are basically at the core of generative AI, enabling human-like text processing or even generation, which is also called natural language processing. But how does this work? Well, LLMs are trained on massive data sets of text to just understand or generate human language, to learn patterns, structures, or even relationships within the data it's trained on. They use these patterns to predict words, phrases, or even entire paragraphs in a given context. And by analyzing a large amount of text, these large language models can understand any fine nuances in the conversation, like the tone or the style, which basically enables them to adapt to any response based on the context which was provided. And as of the current state, we know that they are already capable of processing or generating complex texts with high accuracy and efficiency, making them a very good choice for a wide range of applications, from, again, chatbots or content generation to code suggestion or question answering or even translation. But how can we imagine this? Well, let's say we, the user, we input a query or sentence or question or whatever into the model, which is called the prompt. The large language model then processes this input token by token, which could be a single character or even entire words, and generates a new response based on this very input and the data it was trained on. And yeah, this response is then again returned to the user, which essentially is just a sequence of generated tokens with the highest probability of them being the correct response. So if we think about it, the large language models are just assigning probabilities to any sequence of tokens in a text, which is used to build another sequence, which essentially means that these models don't really think or understand like we humans do, but they rather predict the most likely sequence of tokens based on the data which they were, again, trained on. But enough of that. We've now already heard some examples of how large language models can be used. So let's just recap some of the most common applications really quickly. I've already mentioned the capability of natural language processing, which essentially means that the AI can provide accurate translations across any human language, or it can simply simplify or manipulate any large volume of information, such as articles or any research papers, making them easier to understand or work with. And of course, it's also capable of writing new creative content or suggesting any technical document information and reports, which, as you may think, is not really limited to a human language, because it can also generate code or automate various programming tasks, which in the end enhances our productivity. However, when using any additional modeling tool like a diffusion model, for example, DALL-E or Sora or Runway, AI systems can also generate any multimedia content, including images, videos, and audio. And I think even entire AI-generated films are possible by now. And of course, with AI-powered chatbots, we can handle any, let's say, any customer service inquiry or question and retrieve any domain-specific knowledge. Which brings me to my next point, because we know that large language models are trained on predefined data sets, which mostly don't really cover any specific or even the latest data. So if we were to use generative AI in our custom domain, how can we make sure that the artificial intelligence system can give the relevant information we need? So to feed our large language model with the data we specifically want, we can use something called RAG, which is short for Retrieval Augmented Generation. Let's quickly discuss what that means. So just a short explanation, Retrieval Augmented Generation can be seen as a framework which essentially combines the content understanding and the generation of a large language model with some sort of external knowledge retrieval method or system to enhance the quality and the relevance or the context of the generated content of the overall model. So essentially, by integrating information retrieval with the language generation, these RAG models can produce more accurate, context-aware responses to any query, making them a very good choice for a wide range of, let's say, a special domain application. So how can we imagine this? Well, let's look at this image for a moment. Imagine we have a chatbot, which should answer any question about our product. Now we simply ask a question, and this chatbot interface or this sort of application gives our prompt to the RAG model. And the RAG model then searches or sort of retrieves the information which is needed from the context from our product documentation or a database or whatever to get this company specific knowledge. It stores this information, and based on the stored information, the large language model can then generate a response based on what was said in that information. And this way, the chatbot can provide more accurate and maybe even up-to-date answers to any user question, improving the overall context. What makes these services so popular is they're super easy to use, because we just sign up, connect our application to the services API, and we're good to go with no any further technical setup needed. They're also designed to scale up easily, so we can handle any small project to a massive workload. Plus, the providers regularly roll out new features or improvements in updates, so we're always getting the latest version of this type of technology. However, there are, of course, some things to keep in mind, since these models, kind of depend on the cloud infrastructure. So we would always need a stable internet connection, and we're always tied to a third-party service, meaning we only have limited control over the model and the data and how everything operates. Also, there are privacy and security considerations to think about, especially if we're dealing with sensitive information, which needs to be safeguarded. Now, on the other hand, with self-hosted models using tools like Ollama or Llama CPP, we have a lot more control because we run everything on our own infrastructure, which gives us the full control over both the model and, of course, the data. We could also customize the model to suit any specific requirement or need. And also, this setup, of course, offers enhanced privacy or security because, well, my data isn't going anywhere outside of my environment. But as you might think, this type isn't without its challenges either, because we do need some technical knowledge to set up and maintain our models properly. Also, we do need to have the right and sufficient hardware to actually support the model running. And of course, the responsibility for keeping everything updated and running smoothly, all of that falls on us. So how do we actually decide which one is best for us? Well, let's say we're working with highly sensitive data. Then we might lean towards a self-hosted model because we'll have more control over the security of our data. If that's not possible, we could simply, for example, anonymize the data before using a cloud-based model. Because if we are planning to handle larger or unpredictable workloads, then maybe again, cloud solutions can offer a higher flexibility. And of course, it's always worth comparing the costs of cloud subscriptions with what it would cost to maintain my own local infrastructure. All right, then. I think we've heard enough about AI for now. I just want to add just some small closing words on that, because we've all seen AI emerging in any field right now. And considering all the latest improvements and developments in this technological field, I think it shows us very clearly that AI has definitely come to stay. And we all now have the chance to sort of rethink or streamline certain processes to let us focus on, more important things. Especially with the help of generative AI, we can now automate or augment tasks which would typically require, again, human-like understanding, whether it being your own AI application or just using a powerful tool, which is already available for certain subtasks of the DevOps process. But now, with that being said, I would like to hand the word back to Matti.
Thank you, Paul, for the insights in AI and GenAI. And so now that we have had a look at the traditional DevOps lifecycle as well as AI, let's now take a look at why we would implement AI into this process. First, AI can assist developers and the operations team in making faster and more data-driven decisions. This is crucial in an environment where timely insights can significantly impact project outcomes. Tools such as AI-powered code reviews and test automation enhance the productivity of teams by reducing the manual workload and allowing team members to focus on more higher valued tasks. Moreover, AI helps in bridging the gap in the DevOps lifecycle. It fosters improved collaboration between development, testing, and operations by automating routine tasks and generating insights that facilitate better decision-making across teams. We'd also need to consider proactive issue detection. With AI tools, organizations can predict potential issues in their IT infrastructure, enabling predictive maintenance. This proactive approach allows teams to optimize resources and prevent downtimes. Ultimately, this improves the performance. It's also important in achieving faster software delivery. In the DevOps context, AI-driven tools can streamline workflows, automate testing, and optimize deployment processes. This not only leads to faster software delivery cycles, but also enhances the overall quality of the software that is being delivered by us. In terms of security, real-time threat detection powered by AI can swiftly analyze network traffic, identify anomalies, and respond to security incidents as they occur. And finally, AI also helps organizations manage and enforce governance and compliance requirements more effectively by automating risk assessments, monitoring, and reporting processes. Now, there are already many tools that offer us some capabilities in this DevOps workflow, but why would we want to use them in each individual process of the DevOps lifecycle? Let's first start again with the planning phase. AI plays a crucial role in enhancing decision-making. By analyzing historical data, AI can provide valuable insights that help teams prioritize features and set more realistic timelines. This data-driven approach allows for better planning and reduces the chance of overcommitting or misjudging project scopes. AI also helps in optimizing resource allocation, and it provides insights into team capabilities and workloads, which enhances task organization. To support this, we can use tools like Atlassian Intelligence or, for example, also Forecast. But how does it help us in coding? As we already heard, AI can help us accelerate the coding process. This is done by suggesting code snippets and auto-completing whole functions even. AI can therefore significantly reduce our development time. Furthermore, AI plays a vital role in enhancing code quality. During coding, AI tools can identify errors and provide recommendations based on best practices. For this phase, the most commonly used and known tool would be the GitHub Copilot. For the testing phase, AI helps us increase test coverage. By generating test cases automatically, AI ensures that all possible scenarios are tested comprehensively. For this phase, we can use, for example, tools like FirstMate and TestHim. But FirstMate can also be used and included in the next phase. AI helps us streamline the release and the deployment processes. By assessing historical release data, AI can predict and prevent potential issues during deployments. This proactive approach significantly reduces the risk of failure and enhances the overall reliability of our deployment process. AI also aids in automating infrastructure provisioning and helps us intelligently allocate resources based on our real-time demand, which enhances scalability and ensures the application can handle the varying loads without our manual intervention. Additionally, AI enhances configuration management and can analyze the deployment configuration to ensure optimal performance and reduces the likelihood of downtime. For this phase, we can use tools like Harness and Kubia. And lastly, AI enables teams to proactively monitor systems. By detecting anomalies and potential issues before they impact operations, AI can significantly enhance system reliability. This proactive monitoring ensures that organizations can address issues swiftly and minimize the downtime and disruptions. AI, of course, also facilitates predictive monitoring by analyzing metrics and identifying trends in the data. AI can predict potential failures before they even occur and impact the customer. For this phase, we can use tools like the Dynatrace Davis AI, for example. And now my colleague Paul will tell us a bit more about certain AI tools.
Yes, thank you, Matti, for introducing us to some cool AI tools. Now, to get a better understanding of how some of these tools can actually enhance different phases of the DevOps lifecycle, let's actually take a closer look at some popular AI tools and what benefit they bring to the table. Let's start off with Atlassian Intelligence, or in our case, Jira AI, which enhances the planning phase of the lifecycle. Now, Atlassian Intelligence makes it easier and faster for us to manage tasks and projects. For example, with its natural language search, we can quickly find issues or any dependencies in Jira and maybe get deeper insights by running any complex queries or by simply creating charts, which also speeds up the incident detection by grouping any related alerts, helping us to focus on important ones. We can also suggest any subtasks or relevant items to keep projects moving forward, while certain features like AI-powered responses or even virtual agents can help us to quickly address any customer request. So all in all, we can automate tedious tasks simply by describing them in our plain language, which, again, all in all, saves valuable time. And yeah, as seen on the previous slide, we can, for example, track and filter specific questions or tickets or issues, because Jira is capable of formulating queries based on our natural language, which allows us to quickly get insights or even filter in our current issue list without having to formulate complex queries or whatsoever ourselves. In this example, let's say I wanted to see all issues regarding our mobile app project, which are still in the making process. And yeah, we're just typing the question or the content we want. And with one click, Jira formulates a very complex query based on our description to show the relevant information. Right, let's move on. I'm sure we've all heard about GitHub Copilot, and we know it's a great tool to enhance our coding phase of the DevOps lifecycle. So let's see what it does. Now, as the name suggests, the GitHub Copilot, or maybe other alternatives, acts as a pair programmer. And I like it to imagine as if there was a virtual coworker sitting right next to me and automatically suggesting or even completing code snippets based on the context of my provided code, which helps me to write code faster and more efficiently. Now, of course, the coding assistant is not perfect by any means. And it might not always provide the best solution, of course, because as of the state of right now, we still have to interfere somehow and kind of think of the architecture and the design of our code or the application ourselves. But it does help us to speed up the coding process. And so, just like AI assistants can help us writing code, others can help us with the testing phase of the code we have written in the DevOps lifecycle. So in this case, I would like to talk about a simple yet very powerful tool called FirstMate. But first, remember when we talked about our RAG applications to add a little bit more context or to understand this process a little bit better, I tried to adjust this application architecture to show how, in this case, the FirstMate bot acts as our AI colleague, which sort of asks or retrieves the code by accessing my repository code data, and on top of that, building actionable insights using the capability, the natural language processing capability of a large language model. Now, if you move to the next slide, we can already see the magic behind FirstMate. So let's say if I were to create a new pull request for a new feature of my application, FirstMate would automatically review my code snippets and provide me with actionable insights and suggestions. And in this case, it's giving me tips on how to improve the quality of a demo README file which I've created to adhere to any best practices. But we could go even further and provide our own guidelines for any code changes or even compliance. FirstMates will also analyze my failing pipelines and should suggest ways of potentially fixing them, which can help me to quickly identify and resolve the issues in my code. And in this case, for example, the pipeline checker complains about duplication of certain code snippets in my code, and it shows me how I could address this issue. But that's not all, because FirstMate can also implement suggested changes and create a new pull request for me. In this case, I just have to ping the FirstMate bot using the comment option in this case, a GitHub pull request, and I can simply request it to help me implement the changes it previously suggested. And this will open up a separate new pull request fully created and managed by FirstMate, where it shows me what exactly it did. And this way, I can understand and fix the issues in my code more efficiently and quickly, which can save me time and a lot of effort.
Now let's move on from the testing phase to the release and deployment phase of this DevOps lifecycle. Harness can be a great tool to help us with this phase. Harness offers AI-powered CI/CD capabilities that fully automate pipelines for multi-cloud, multi-region, and multi-service software deployments. It enables teams to build code faster in any language and on any operating system that we want to build them on. Furthermore, Harness is also not confined to just CI/CD, but offers many other AI solutions in the DevOps lifecycle. This includes the code assistant and an artifact registry, for example. But in this screenshot, we can see that the AI found some issues during our deployment phase, and it automatically rolled back the deployment for us. Last but not least, we now move on to the operating and monitoring phase of the DevOps lifecycle. The Dynatrace Davis AI is a great tool that helps us with this phase. The Davis AI is at the core of the Dynatrace platform and features multiple use cases. First, we have the predictive AI. This provides us with capabilities for continuous forecasting and anomaly prediction across application traffic and service load. It's designed to be pattern aware, meaning it takes into account historical trends to make accurate predictions. Next, we have the causal AI. This tool analyzes observability and security data within the context and topology of topology information, and it groups anomalies, pinpoints their root cases, and automatically prioritizes them based on the business impact. And lastly, we have the generative AI, which can be seen in the Davis Copilot, which leverages these insights from both predictive and causal AI, and it creates queries, notebooks, and dashboards to simplify analytics. We can see this here in an example. We can use natural language for visual analytics. We just have to tell the Davis Copilot in the natural language what data we want to visualize and explore, and the Davis Copilot then can generate dashboards and notebooks to leveraging the causal AI context. But to effectively and efficiently integrate AI tools into our traditional DevOps processes, I think it's crucial to approach the setup and the implementation strategically. Therefore, we have compiled a comprehensive guide on how to assess and implement AI tools in our DevOps workflow. We should therefore start by thoroughly analyzing our current DevOps workflow to pinpoint areas that could benefit from AI implementation. For example, there are repetitive tasks that consume valuable time, bottlenecks in our workflow, and areas prone to human error, as well as processes that could benefit from predictive analytics. All of these are pain points and opportunities where AI can help us the most and have the most significant impact. And once you identified these potential opportunities for AI integration, the next crucial step would be to evaluate tool compatibility with our existing DevOps toolchain. Key factors to consider here include the integration with capabilities with our current CI/CD pipeline, the compatibility with our version control system, as well as its ability to work with our preferred cloud platforms.
Right. Now, last but not least, let's quickly talk about how to implement these AI tools into our workflow. So if we were to actually implement these tools into our DevOps lifecycle, we tried to provide a small guide on how to actually do this. So first of all, start small and iterate. What do we mean by that? Well, when you're introducing AI tools, it's maybe best to start with a rather, let's say, a small pilot project or a single process, because this way you can test how the tool works without disrupting any of your entire workflow. So by starting small also helps you to gather feedback from your team and spot any integration challenges early on, so you can make any adjustments before thinking of scaling up. Also, for AI tools to be effective, your team needs to be, of course, comfortable using them. So it's maybe best to offer some sort of training session or ongoing support to help them to just, get the hang of it. And it's also a good idea to encourage knowledge sharing, so team members can actually learn from each other's experiences and build inter-team expertise. Also, to understand whether your AI tools are working as intended, it's also a very good idea to regularly track their performance. So try to set up clear performance indicators to measure any success or failure, and actively collect feedback from users, stakeholders, and of course your team. And you can use this data to guide any future improvements or even adjustments. And of course, with all this promising technology, we shouldn't forget that these AI systems should actually augment human capabilities, but not replace them. Because even though AI can automate and enhance processes, we know it can make errors, and it's important to keep us humans in the loop. So establish clear guidelines for when and, of course, how these AI tools should be used, and you should regularly review the outputs they generate. And of course, for important decisions, human judgment should always play a role. And of course, integrating an AI system or a tool isn't just a one-time task. It's rather an ongoing process. So stay updated on the new AI capabilities or any features which could come up, and regularly reassess your AI strategy. Because if a tool isn't really meeting your expectations, you should be ready to make some changes or even replace it with something that just works better for you. All right, I think this concludes our presentation of AI and DevOps, and I hope we've made you hungry for more information. And on behalf of my team, I would like to thank you all for your attention. Now, before we get to any questions or discussions, I would like to introduce a special guest from FirstMate today. Yeah, thank you for joining us today, Jochen. Yeah, would you like to add anything that was said about FirstMate, or are there any insights you have, or any comments? Or
Yeah, yeah. First of all, thanks for having us here. Right, it's really great. Um, yeah, I think you did a great job by explaining it with the rec symbol or animation, or I don't know the word, but it was really great to explain it. And it was really beautiful. But I want to add on it is why AI should be compared to a human today, or what is the advantage of AI today with a human, right? And if you look at it, a human is much better in thinking on stuff, right? Thinking things through is much smarter. So we should never think AI is a human and we can replace it, as you said.
yeah.
Agree on that. But AI has some advantages on a human brain, which is the context switching, which is really important, and a focus span on boring things. These are two things that really, as a human, we come short against AI, in my opinion. And that's what FirstMate uses as a superpower of AI in code reviews, which can be really boring, right? So sometimes you're thinking on your own business stuff, your own implementation. You have to review your colleague, and yeah, it's a bit boring. You have to switch context, and you have to have a look on code from a lot of perspectives at that point. So you see that you have to look from security standpoint, compliancy, financial, architectural, business documentation. You need to update all these things. You have to look at it. And for me, that's a lot of context switching from where you are. And I see AI being very good at that. You can immediately say, now look from a documentation point on this code, or a financial point on this code. And yeah, that's really powerful. And that's why I think FirstMate is good with using AI and is in the right place.
Yep. Thank you so much. I think these are great insights from your side, and I have to admit I'm on your side, because I think, as you said, AI can really help us to speed up some, let's say, tedious or lower end tasks,
Yeah,
and leave us humans with sort of the higher task, or being the brain behind all that, and orchestrating everything. So
yeah,
thank you for your insights. Very great. So I think we have a little bit extra time for any questions or any discussions. So if anything's unclear, or you would like to add any feedback, feel free to ask them now. I think we can wait a few more moments, and yeah, we'll see if anything comes up.
We have a question. Will AI replace humans? We've already mentioned this in our presentation, but I don't think AI will fully replace humans. AI should be a tool to augment human capabilities and enhance our workflows, making it easier for us to focus on more important tasks instead of completely replacing us. Since AI is not really a human, and oftentimes we need a real human thinking behind, a real brain behind the operation, we can't have AI replace us like this. It's simply not feasible.
Yes, very good said. Sorry, I didn't want to interrupt you.
No, please.
Okay. Now, yeah, I think you've said it correctly, because as I've said earlier, and of course Jochen explained earlier, AI is very good at doing some repetitive lower end tasks like coding or checking our stuff better than us, because it has the advantage of its massive context awareness, which we humans often do not have. And yeah, I think that covers it. Well, if there are no questions right now, or there are any other questions, you can always feel free to reach out to us at any time, and we're always happy to help or answer any questions you might have. Again, thank you for joining, Jochen, from the First Mate team, and providing us with the tool for our showcase in our presentation. And yeah, I think if there is nothing more to say, I would call this meeting adjourned and wish everyone a great day. So thank you. Bye-bye.
Thank
Bye-bye.
you. Bye.
Thank you.